Okay, so curve sketching, okay, is what we're after here. But this time we're doing curve sketching by looking at a graph and coming up with another graph based off of this, off the first one. Okay, so curve sketching. We'll call this curve sketching 2. Okay, basically graph to graph. We can. Let's get through this first, okay? And if we don't touch the homework until the next day, then we'll go over that tomorrow, okay? I want to get through this stuff. All right. So curve sketching from graph to graph, okay? Basically, everything we've been doing so far, okay, we've been analyzing an equation and finding all these bits and pieces of it so we can draw the equation. Here, what we're going to do is we're going to have a graph of, usually a graph of the derivative, okay? And from that graph be able to piece together what the original function looked like, okay? So it's sort of kind of going from a graph and going from what we know about the first derivative test or the second derivative test and things like that to reproduce a graph of f of x, okay? So this is where you're essentially analyzing a graph, okay, to then sketch another graph, okay? Okay, and we could do this either for, we can go from first derivative to original graph. We can go from first derivative to second derivative. We can go from original graph to first derivative. We can go from original graph to second derivative, okay? So there's lots of different ways, and it all goes from knowing what the pieces mean.
Does that say to the sketch?
To the, yeah. Analyzing a graph to sketch another graph. I guess I didn't need the word "the" in there. Thank you. Okay. All right. Everyone got that though? What we're up to here? So we're going to basically be doing the same thing we did, okay, with the equations we were looking at, but this time do it with a graph instead. Okay. One big thing, and this is the thing a lot of people always have trouble with when they're doing this for the first time. Two things you got to be very mindful of. What graph we're given originally, okay? Because a lot of people, when they make a mistake, they make a mistake because they're like, they look at it and they think, oh, this is what f of x is. But it could be a graph of f prime of x, okay? So, because remember, the graph it is going to determine what each of the pieces mean. So you've got to be very careful there. The other big issue that a lot of people have is the fact that a lot of times this tells you where on the x-axis these things occur, but it doesn't give you any information about where it occurs on the y-axis, okay? So you could end up getting multiple different graphs, okay? What this will do, a lot of times what this analysis does is give you a basic picture of what the graph should look like, okay? Think of it as a map without a starting point, okay? So if you remember the Indiana Jones movie, Last Crusade, they have the map to the Holy Grail, but they don't know the city to start at. Yeah. This is basically what we're doing here. We're to create the map, so we know exactly where things are and how we should approach them, but we won't know, are we down low, are we up high, you know, are things stretched out this way, etc. We just know the basic locations of things. A little bit later on, we will be able to kind of fill in some of those gaps, okay? So we'll be able to tell where two maximums are in relation to each other, or where a maximum and minimum are in relation, because there are ways you can do that, okay? But right now, we don't have the tools to do that, and we're not going to get the tools for that until the winter, so do keep that in mind, okay? But let's go ahead and take a look at how this works. So let's start off with an example, okay? We'll go through. And here's my example. We're going to do f of x here, f prime of x. So this is the graph we're looking at. It's a graph of f prime of x. And this graph is going to look kind of like this right here. I'm going to go ahead and mark some locations on it for us so we have some things to be based off with. This is going to be, we'll call this as x is minus 3. This is x equals 0. We'll call this one x equals 2. This point here occurs when x is equal to 1. And this one occurs when x is equal to negative 1.5. Okay? Now, from this graph here, I can tell a lot about what f of x is doing. Okay? For example, will f of x have critical points?
One and negative 1.5.
Is that where it will have critical
Oh,
points?
wait, no, that's a lie.
No.
Okay, why 0?
Zachary, you're kicked down if you're lying.
Okay, so remember, f of x has critical points when f prime of x is equal to what?
0.
0. So this is a graph of f prime of x. Where's f prime of x according to this graph equal to 0? At -3, 0, and 2. So those three locations here, which I will now color, these are where f of x should have a critical point, okay? So f of x has critical points at x equals -3, 0, and 2. Not only can I tell that those are critical points, I can also tell which ones are maximums and which ones are minimums. Okay? Remember, a maximum occurs when the derivative does what? It goes from what to what? Positive to negative. So, where does this graph go from positive to negative?
At -3 and 2.
And -3 and 2. Notice I was positive before -3 and negative afterwards. So that's a maximum for f of x. Okay? Again, at 2, I went from positive to negative. That's a maximum for f of x. Where's my minimum then for f of x?
0.
0, because that's why I go from negative to positive. Okay? So not only can I find my critical points for f of x from f prime of x, I can also determine what's what. I have maximums at x equals -3 and 2, and mins at x equals 0. Excellent. Okay? Now, I can also tell things about increasing or decreasing intervals, right? Okay? F of x is increasing when what is positive?
What did you say?
Okay, so f of
Y
x,
is positive.
when what's positive?
When Y is positive.
Okay, so not just y is positive, but alright, you're on the right track. Basically, f prime of x, when it is positive, that's going to be where f of x is increasing. Okay? And likewise, when f of x is negative, that's where f of x is decreasing. Okay? Because remember, f prime of x is representing the slope of f of x. Okay? So, where is f prime of x positive?
Less than when x is less than negative
So basically from -infinity to -3, and then from 0 to 2, right? So I come through here and say f of x is increasing when on the intervals from -infinity to -3 and 0 to 2. And where would it be decreasing? -3 to 0 and 2 to positive infinity. Okay?
Do you always put an open interval whenever it's
Yes.
ready?
Yeah, use open intervals when you're talking about decreasing, increasing, concave up, concave down, that sort of thing.
So how do you know it's incorrect? Like,
Okay, 1 second. Jim.
so with places like x equals 1, that be maxes, and x equals -1.5, that be mins.
We'll talk about that in a second. Yeah, but yes, there are not maximums and minimums for f of x. Okay? Okay. Now, to answer your question from before, you were basically saying, what were you asking, Chip?
Like, I'm wondering, like, how you know, because from -infinity to -3,
Uh-huh.
I understand how that's,
How that's increasing?
yeah, and then
Okay.
decreasing, you say -3 to 0.
So, remember, this is all information for f of x. Okay? This is a picture of f prime of x. Okay? So, f of x is increasing when f prime of x is positive. Well, where is f prime of x positive? On that zone right there, and on this zone right here, right?
Okay.
That's where f prime of x is positive. So, those zones, those intervals correspond to where f of x is increasing. Likewise, okay, so this is increasing, f of x increasing. Likewise, that zone and this zone is where f of x is decreasing, because that's where f prime of x is negative. Okay?
Yes, sir.
Better?
Yes, sir.
Okay. Now, the other question is, okay, so wait a minute. Negative 1.5 and 1, they don't correspond to maximums or minimums for f of x. Okay? Well, then what are they? Well, what's the slope of f prime of x at x equals 1? 0. Okay? And so, what represents the slope of f prime of x?
F double prime.
F double prime of x, right? So, at 1, that's where f double prime of x is equal to 0, correct? So what does that make it?
Point of inflection.
A point of inflection, okay? Basically, the maximums and minimums for f prime of x are the points of inflection determined by the second derivative. They're the points of inflection for f of x, okay? So, I can come through here now and talk about concavity of this thing. I could say f of x has points of inflection at x equals negative 1.5 and x equals 1, right? Because those are the two locations where f double prime of x is going to be 0. Okay? Again, all determined by this graph. That can also help me tell what the concavity is doing. Okay? When is f of x concave up?
X equals negative 1.5.
Okay. Don't look at this graph here. Okay? F of x, that's concave up when what is positive?
If you have a maximum, then it's going to be concave down. If you have a minimum, it's concave up.
Okay, so you know that, but think in terms of derivatives and second derivatives and things like that. Okay?
Oh, when the second derivative is positive.
So you're concave up when the second derivative is positive, and you're concave down when your second derivative is negative, right? So,
How do you jump up this graph?
well, second derivative is just going to be the slope of the first derivative, right?
Right.
So, where the first derivative is decreasing, that's where f double prime is negative. So I'm concave down
How do we know what double prime is?
right there.
It's the slope of.
Okay. So I'm concave down again, right here.
So the point of inflection is the one that aren't on the x-axis?
Right. So,
That's when it's changing direction.
Yep.
But it's not sharp. So what about in the middle though?
okay. So in the middle, I'm concave up. Concave up from negative 1.5.
So why would you be, okay, no, okay.
Okay.
So concave up is just when the graph's going up.
Concave up is when the graph of the derivative is going up. Yes. Okay.
So it's concave up on the interval from negative 1.5 to 1.
Yep. So I can come through here and say I'm concave up. And concave down everywhere else.
From 1 to positive infinity, right?
Yeah, and from negative infinity to negative 1.5.
Oh, so the concaves are from inflection to inflection.
Yep. So there we have it, okay? Again, it's from what I know what these things mean, okay? Basically, if I go through here, maximums and minimums, critical points, determine where f prime of x is equal to 0. From my graph, I know exactly where those are, okay? Increasing and decreasing is determined when f prime of x is positive or negative. Again, from my graph, I know where those intervals are, okay? Points of inflection, okay, those are determined by the second derivative, but I can figure out what the second derivative should be from the first derivative, right? When the first derivative has a maximum or a minimum, that's going to be a point of inflection. And when the first derivative is increasing or decreasing, that's going to correspond to concave up or concave down. Okay? So all of this information about f of x, I was able to figure out from the graph of f prime of x.
So
Okay.
like, what would be like the written out form of this, like an equation for this? So
Well, we don't know. Okay? We just know what all the pieces are, and then what the thing should look like. In fact, what I'm going to do now is go through and do a basic sketch of what f of x should look like from this information. Okay? Again, though, I don't know precisely what it will do. All I know is where it has maximums, where it has minimums, where it's increasing, where it's decreasing, where it has points of inflection, and where it has concavity.
And why do you have to write f of x when you're doing this, yet the graph is of f prime of x?
Because that's what we're trying to find. We're trying to figure out stuff about f of x based off of the graph of f prime of x. Okay? Yes, David?
Can we use sign analysis for the concave up or concave down, or do we have to look at the graph?
Well, if I had an equation, I can use sign analysis, but I don't have an equation, so that's why I'm looking at the graph.
But even if you plugged in the point, or oh yeah, makes sense.
There's no point, I can't plug in anything because I don't know what the equation is, okay? But I do know from the graph what the behavior should be, and that's what I'm filling in here. So, what does f of x look like then? Okay?
And we're gonna, so are we always gonna be given like the f prime x, the first derivative, and then have to give the function?
Yeah, or basically do a sketch of f of x, yes. This is a very common AP question, by the way, okay? In fact, the take-home AP that's due on Friday, okay, is basically just one of these. You're just going through a graph of f prime of x, pulling out all the information from it, answering the questions, and then the last part of it is give a sketch of f of x. So what should f of x look like? Well, we know f of x had maximum at -3 and 2 and a minimum at 0. Again, I don't know where on the y-axis that's going to occur, but I can at least guess and kind of put them relatively where they should. So we'll put our minimum right there, and our two maximums, x equals -3 and x equals 2. Okay? Again, I don't know what the y coordinates are. What I do know here, though, is that at 0 is a minimum, so it should be below 3 and 2, right? Likewise,
Yeah.
x equals -3 and x equals 2 are maximum, so they should be above x equals 0. Okay? The other thing I know, too, is that points of inflection are going to always happen in between a maximum and a minimum. Okay? So, x equals, my points of inflection, x equals -1.5, which is about right there. And x equals 1, doesn't matter where I put it.
Yeah, so how do you know where it is on the y-axis?
I don't.
You can just put it anywhere.
You can put it anywhere. All we're doing at this point here is making a, we know where to look, we know what these points are, so we know what they are in relation to each other, but we don't know what the y is. Now we can figure out what y is later on, okay? Or at least we can figure out later on when we get there how far -3 should be from 0 and 2 should be from 0 and things like that.
So that's
Okay.
all we'd have to do if you asked us from.
Well, last thing is connect the dots,
Okay.
okay?
So, Mr. Dowell, the points of inflection are where the concavity changes?
Yep. And so, without knowing anything else though, I'm able to get a rough sketch of what this graph should look like, so this thing should look kind of like an M. Okay?
Why does it go back down?
Oh, these are maximums, right? So the maximum, it has to go change direction and go back down.
How does the concavity change at like x equals 1?
X equals 1,
Yeah.
I went from concave up, which is what I'm doing in the center here, to concave down, which is what it's doing right over there.
And it's in between those 2 points?
Yeah, somewhere in between 0 and 2, my concavity had to go from being positive to negative.
And it's directly between the two, the x value is directly between the two
Well,
x
because
values.
that's what we were given from the original graph.
Uh,
Okay, we don't, it could be, it doesn't necessarily have to be there. It could be like close to 2, it could be down by 0. But the original graph I gave you had that point be at x
Yeah.
equals 1. And so that's why I put it there. Now, again, where it is along here,
No,
had no idea. Okay? And just like this, again, I don't know what y is going to be doing here, but I do have a good sense of what the graph should look like. This thing could be all entirely above the x-axis. Could be all entirely below the y-axis, x-axis. We don't know. Okay? Some of these things could be 0. Some of these things could be other things. All we do know is that this is the relationship between them. This is what it should look like. Later on, when we study integrals, we'll be able to use the area in here to determine how far away those points should be. Okay? But until we got that, again, we still can't do much more. Okay? And even then, even if we knew that, we still wouldn't know where the exact values of y because we wouldn't have them. Okay? You'd have to be given that x equals 0 happened when y was 5. If we had that, then we could go through and start putting in things correctly. Okay? But until then, we're just stuck kind of with this basic sketch. Yes, Chaz?
So x equals negative 1.5 and x equals 1.
Uh-huh.
You just randomly plotted those knowing that
Yeah.
negative 3 and 2 were maximum, so that would be the highest.
Uh-huh.
0 had to be the lowest.
Yep. I knew they were points of inflection from my analysis of f prime of x, and I know a point of inflection has to happen between the maximums and minimums. Okay? Which is why I put them where they are. Okay? Where exactly they are, though? Me? Don't know. Okay? They don't necessarily, 1.5 doesn't necessarily have to be right here. It could have been closer to 0. 1 could have been closer to 2. Okay? We're not sure without having any other information. Okay? But from what we're given, okay, this is a pretty approximate graph of what this thing should look like. Okay? This tells us basically what f of x what we should expect from f of x. Okay? Everyone understand that? So I should expect f of x to look kind of like an m. Okay?
Do you have, like, if the entire graph right there, or maybe just the point x equals 0 was above, like, y equals 0, would that, I mean,
Doesn't change
you
it.
just put that there because you just, okay.
Yeah, basically, I put it there just to demonstrate all that matters, okay, William, is that x equals 0, because it's a minimum, it's beneath my maximums, okay? The fact that it's down here in negative territory doesn't matter. It could be up here in positive territory, okay? I just put it down here because that's where I felt like putting it, okay?
Okay.
And also, too, it's easier for me to stick it down here when I'm doing this kind of like sketching, because then it helps me to say, okay, I know that's the bottom point, those are the higher points, and so I know there's a clear difference there, okay? Again, it could be like this, it could be like something else. We just wouldn't know unless we had more information, okay? Remember, all we're doing here is creating an approximate graph of f of x. This is what f of x should look like, okay? It should do something like this here, okay? And so we were able to figure out all that out from f prime of x, okay? All right, now that we've got that. By the way, I don't have to do this just for, I could also do this for other graphs as well. For example, I could start with a graph of f of x and figure out what the derivative should look like. Basically doing the same exact method here, okay? Let's go ahead and do that, okay? So another example here.
Would you ever have us go from like f of x to double prime of x?
Yeah, you can do that, okay? It doesn't happen often, but you can, okay? Typically going from the higher one to the lower one happens. Going from the lower one to the higher one. Going from double prime to the regular graph, less likely, because remember, every time you take the derivative, you lose even more information.
Yeah.
Okay? Now, we can use f double prime of x and figure out some things, because we can use f double prime of x to figure out things about f of x, or f prime of x, and basically doing the same process here. Okay? And then, from that graph I get of f prime of x, be able to figure out what f of x should be doing, roughly speaking. But again, I've lost a lot of information every time I take the derivative. Okay? So, but another example here. This time we're going to go from the original graph, so this will be g of x. Okay? And we're going to get g prime of x from it, okay? So g of x will make, I don't want to do that M shape, hang on. Let's do it as, here's what we'll do, okay? So, the things I'm going to note on g of x, I'm going to note this point right here, this is where x is equal to -2. We'll make this x equals +2. And for the heck of it, I'm going to mark one more point where x is equal to 0, okay? Right there in the center, okay? Well, from this graph here, I can tell some things about f prime of x. For example, where g of x has a maximum or minimum, that's where g prime of x is equal to 0, right? So what are the zeros for g prime of x?
2 and -2.
2 and -2. Okay? Where is g double prime of x?
Well, it has zeros at -2 and 2.
Okay.
It's not crossing.
Okay. It has zeros at negative. G prime of x
Okay.
has zeros there because that's where g of x has maximums or minimums. Okay. We're doing the same thing we did. We're doing the same process as before, Jim, but we're doing it in reverse.
Yes, sir.
Okay. G prime of x. Where is it going to be positive and where is it going to be negative?
It's gonna be positive
From the
-2
-2
to 2.
-2 to 2. Okay.
So zeros are the same place for max and min?
Yep.
Okay.
And so it's 0. It's less than 0 everywhere else, right? It's negative from
Negative infinity to negative
-2 and
from 2 to negative positive.
Are we allowed to say that on like the AP? Say everywhere else it is, or is
get in the habit of writing out the interval completely. It's just safer.
right?
One of my tests, you could say everywhere else. I would not care. I would say that's fine, because that is the case. Everywhere else is negative. But a large portion of the AP exam, remember, they want notation to be as clear and as concise as possible. Okay, so saying everywhere else, some stickler could come through and be like, well, everywhere else would include 2 and -2, and that's where it's 0, not positive or negative. So it's wrong. See what I'm saying? It's sort of one of those like, here I am mocking people I don't even know, but that's the danger. You don't want to run into anything like that. Okay? Yes, Jim?
What is the second part dealing with? Is that
Where-
increasing in
Basically, yeah. So I know g prime of x, the derivative is going to be bigger than 0, so it's going to be above the x-axis when g of x is increasing, which happens from -2 to 2.
Okay.
Okay? Likewise, it's going to be below the x-axis when it's decreasing. Okay?
Okay.
I can also come through here and tell things about concavity. Okay? Where is the second derivative going to be positive, and where is the second derivative going to be negative?
No idea, Mr. Moore.
X is
Positive.
0 to negative, or 0 to infinity is positive.
Is not positive, negative there, because that's concave down. Oh, go back.
Oh, wait.
This is concave down there. This is concave up here. Okay? So we made the assumption 0, the marked point x equals 0 is a point of inflection. Safe to assume that. It's between the two, so it probably is. Okay? So we could say g double prime of x is equal to 0 at x equals 0. And we're concave up on the interval from -infinity to 0 and down from 0 to infinity. Okay? What that tells me, by the way, not only does that tell me concavity, that tells me, remember, where f prime of x is increasing and where f prime of x is decreasing. F prime of x is increasing, or g prime of x, excuse me. G prime of x is increasing, okay, between -infinity and 0, and it's decreasing, okay, from 0 to positive infinity. Okay? Again, all gotten from this original graph here, okay? So I can come through now and do a decent sketch of g prime of x, okay? I've got zeros at -2 and 2. Okay? My point of inflection is at 0, and that point of inflection, okay, is a maximum for g prime of x. How do I know it's a maximum, not a minimum? My concavity went from positive to negative, so somewhere along here, this is where x is equal to 0. And so kind of filling in my curve, I should end up with a parabola that looks something like that. Okay?
Wait, where'd you get the x equals 0 for?
That's the point of inflection for g of x, which is going to be where g prime of x has a slope of 0. Okay? Which means it's a maximum or a minimum for g prime of x.
And we were able to find the point of inflection because it's between the maximum and the minimum.
Yeah. We know there should be a point of inflection somewhere between these values here. Plus I marked it. And so from that, we're able to use that information to create our graph. Okay?
Wait, so you just made x.
That was given that it was going to be a point of inflection. Interesting.
That's
Hold it. I'm saying after. Two more corrections in.
Stop this right here.